Good evening. I want to welcome you on our last lecture from this year. Our guest is Guido Brandi from Zurich. He's an architect and he founded his office right now this year actually by winning the competition in Switzerland. So congratulations. And Guido is also researcher and working at the university, like Zurich University of Applied Sciences, and that was the main reason why I wanted to ask him to introduce his publication, Reuse in Construction, which was made together with your colleagues Andreas Sonderegger, Eva Strich, and Baubüro in situ. Yeah. Yes, I think these topics of sustainable topics and the topics of reusing and the material and implementing it in the construction process are quite discussed also in our university, but mostly in the design studios. So not maybe it's not really the part of the curriculum of our faculty, so it's also the reason why I'm quite happy that you can introduce us, your working with the students and your research projects and so on. So thank you for coming and enjoy the lecture. And also I want to thank you all for coming to our events. And yes, thank you.
So, thank you so much, Miroslav, to invite me here. It's really nice because we had the chance to work together in Zurich some years ago in the same office, me and Miroslav, and already maybe 8 years ago, something like this, or 7, 8 years ago. So, or maybe even more. Okay, good. And it's really nice to be here tonight. So, as Miroslav said, I'm an architect, but also I'm a researcher at the university. And so I'm doing this double role, so doing research, following other projects about reuse, circular construction, but at the same time, being an independent architect with our office NUAR, trying to develop even more in the practical world those topics of reuse and reuse of building elements. So I'm going to show you here, maybe so just to show you the lecture how it's organized. We go through a bit of glossary. So what does it mean to reuse? What does it mean to think about circular architecture? Why reuse is important, at least for our point of view. I show you the case study K118 is this really, I think, right now famous building planned by Baubüro in situ in Winterthur. The build already was finished now 3 years ago. The main findings that we had, we discover about reuse, and then some look in the future, what is happening right now in Switzerland, about this topic of circular architecture, reuse of building elements, what is happening in the real world of Switzerland. So, as I said, a glossary, As you see here is this scheme that is come from it's a cycle diagram based on the life cycle model according to the European law. It's interesting to see that when we speak about construction, we always speak about a linear process normally. So if you see, there is a raw material supply, then a transport to a manufacturer, and then a transport to the construction site. Then there is suddenly a building, an existing building having its own life, and a life cycle, let's say, and then suddenly, somewhere in the future, is going to be demolished, dismantled, and then the elements are going to be brought in waste processing and then in disposal. No? And when we think about circular construction, we always try, as you can imagine, to close this linear process and to transform it in a circular one. But we always think about there are 3 different layers of circularity. We like to speak about this, no? From the brightest to the smaller one. Of course, the smaller one is the most sustainable process we can have. So the smaller one here, the preservation of the building as it is. So to enlarge the life of a building, this is always the most sustainable things to do. Another process, another circle, bigger one, is the recycling one. So when already the building is demolished, it doesn't exist anymore as object. Also the singular component, like the slabs or imagine windows and so they are destroyed in small elements, they are recycled, right? And so in this way also the circle is closed, but of course the materials pass a lot of processes. We as a researcher in our university, we are really interested in this middle path, no? Middle circle, the reuse of element. So it means to reuse entire component as they are without losing of their form, their characteristics, their qualities, and try to reuse as they are in new building. And well, maybe just to add something is interesting because you know that the recycling process are really broad, so they're really bright in the industrial process nowadays. The preservation, the reuse of building as well. But this reuse process, try to reuse the component as they are, is really a niche. It's something really complex right now. It doesn't fit to the industrial process. And it's kind of strange if you think about this, because actually reuse of building element is part of entire history of architecture. I always bring this example, the Colosseum in Rome, that for me is always funny to show, because nowadays the Colosseum is a ruin in the center of Rome. It doesn't work anymore as an arena, as a stadium, but not because the people couldn't maintain it, try to maintain it as a stadium, as a working arena, but just because in the Middle Age, in the Renaissance, the rich families of Rome used the Colosseum as a mine, as a urban mine, to take all the stones and create their own new palaces. So, because this is really the point, before the Industrial Revolution, every component was always reused. And there are many examples like this. I can show you. So the dome in Pisa, where most of the marble are reused, or the Basilica in Venice. That here is also interesting because almost every column comes from different parts in the Mediterranean Sea, showing also the power at the time of Venice. So the reuse of structural element was at the time also a way. It was called the spolia, to show, to add an additional meaning on the elements, to show a sense of power. So reuse of building elements for us was also interesting because you can have an additional meaning of it. But now I show 2 examples from, let's say, from the Catholic world, but actually in the Arabic world, there was also the same process. In Tunisia, this mosque reused Roman pillars to produce all the arcade around the courtyard. And it's interesting to see that also in the Alpine world, in the mountains, and also with other materials, in this case wood, the process of reuse was also done, was also, so there was investigation in it. This is let's say, a fair and a holiday house planned by this Italian architect Mollino that reused an existing building, a silos building for the grain in the mountain. They just dismantle it piece per piece. They transport it on the other side, on the valley, and they create this. They create a new platform on it, a new staircase, but they recompose it, creating this holiday house. And so here was also interesting to see. So what does it mean to work with reuse element? No, you want to show what are the old parts. You want to show, differentiate, and show the new parts. And it was interesting to see for us that also with wood element, this was developed. But even an iconic and famous, one of the most famous projects of the modernism, Capella Ronchamp from Le Corbusier, actually is also with reuse something to do. All the stones of the existing church that were on this hill that was bombed in the Second World War were then reused as a filling element for all the walls. Or another amazing project from Plečnik, the Church of Saint Michael, and where he reused, or those are new elements, but those are concrete pipeline used for canalization that suddenly put in a vertical way, and with some decoration on it, they became church pillars. So to transform something industrial and really, something industrial and something really sacral somehow. This is not reuse on an existing element, but of course it has an inside also this idea when we as architects, we work with reuse. We have always to think how we have to analyze the things we see in front of us, the element, and try to find a way to think about different use for it. This is an image of almost a temporary artist shelf, almost a pavilion in Zurich, and it's interesting to see that in the last 50 years, or let's say at least in Zurich in the last 30 years, this was the idea of reuse, no? It's more this do-it-yourself. You take what you find, some different windows, some metal sheet, some staircase, you put them together and you create a space. This is in the image of everyone reuse, but somehow, as I said, it's strange because these are two nice sketch from one is from Leon Krier, showing how we always used to build through the whole history of architecture, we used to build and plan houses in the same way. Then came someone called Le Corbusier, also in the modernist moment, changing completely the way we should plan. And of course, this was full of postmodernism thought to say we should go back to planning normal building. And so Daniel Stockhammer was also a researcher in our university, now is in Liechtenstein. Based on this sketch, he did also this sketch showing how the history of architecture was done with reuse. And just in the last 50 years, we start to demolish everything and treat components as waste. But before 1950, or at least before Industrial Revolution, there was no waste in construction industry. And again, to say we should go back to the same process. And so, but why reuse is important, at least we consider important. You see in this image, an office building in Zurich that after 28 years old was completely demolished because of the economical pressure that we have right now in Zurich, and was demolished some like 5-6 years ago, and already there is in place of it there is a skyscraper, high-rise office building. And this is crazy to see because an image like a building like this has an enormous quality. It had 3 glass, so aluminum windows with 3 layers of glass, stone facade coming from a different region from the Alps. You can imagine the entire partition, internal partition, the doors. There were a lot of staircase, outside staircase in steel. And this was the result, right? And luckily, Baubüro in situ could manage to reuse some of those elements and to transfer them in the K118 that I'm going to show you later. And so, again, why reuse? Why we think is important? Because if we consider, at least from the point of view of the consume of CO2 emissions, no? Gas emissions, gray gas emissions, when we see all these phases in the linear process, there's I realize now it's in German, but it's the production phase at the beginning counts for 75% of the entire emissions. The construction phase, just 10%. And the moment from the moment we demolish a building, the entire emission are something like 15%. So if we manage to take this shortcut, we suddenly save 75 plus 15, almost 90% of CO2 emission. And of course, this is theory, because we cannot save directly everything and reuse completely everything. It's still in theory, but this makes you think how effective could be reuse of building components. And there is no such a effective way, because, for example, if we do recycling, in Switzerland there is also a lot of this industry. So, for example, recycling of concrete, no, saying no, we are saving the planet, we are recycling the concrete, but actually you are just saving maybe 15% of the emission, and to produce this recycling concrete, you have to put the same amount of new cement in it, actually even more. So, and actually in the production of concrete is the cement the real problem, because you have to burn the clinker 1000 degree height. So, and there is no such effective way as this one. But as well as we know, is a niche, is also the most complicated one. And there are many offices dealing with this topic. Miroslav told me also you had Rotor this year, right? So some weeks ago, actually. Last week, yeah. And so there are many architecture offices in Europe dealing with this theme, with this topic. And we will focus on Switzerland, where the pioneer is Baubüro in situ. And I will tell you the story about this building here, K118, that was built, built 3 years ago in Winterthur. And Baubüro in situ, maybe you know it, was the founder of Baubüro in situ was Barbara Buser, founded in 1994, and she was really a pioneer in Switzerland in the topic of reuse. She even founded this Bauteilbörse in Basel, so it's a place where you still today you can go there and buy refurbished lavabo, sink, tiles, or even technical elements, or let's say a washing machine, fridge, etc. And she was luckily, because she's really politically involved in many different things, she also worked a lot in reusing, transforming industrial area, and so she was in the board of director of this foundation, pension fund foundation, Stiftung Abendrot, that they bought this area in Winterthur in something like 2008, I think, but I'm not sure. The thing is, they bought this area to develop it, but in a way not to completely, because there are many maybe firms that they can say, okay, we can buy this industrial area, we tear everything down, and we develop it as maximum as possible. But they have really this approach that they want to maintain as much as possible, try to change the program, try to have a really mixed society in it. And so for them, it was really important to maintain the industrial substance of this place. And they had to develop the K118, so this building in the middle of the area. And Barbara Buser came up with the idea to say, okay, let's try to do a really lighthouse project. Let's try to reuse as much as possible every element and to create really something new that no one has seen. It's interesting because this is the Department of Architecture. So we are in the same industrial area. We are really close to the building, so we could follow the entire process from the beginning till the end. And so as you see, this is our aerial view, this is the department, and this is the Kopfbau 118. And me, with Eva Stricher and Andreas Sonderegger, we could manage to analyze the entire project from the beginning till the end. And now I'm going to show you what we learned from this project. And I will showing you using the diagrams, the graphics that we developed for this book. So, as I said, this is the building as it was. It's a nice industrial construction, so steel structure filled up with a layer of brick. And this is the result at the end. I'm going directly to the end. No? It's an additional building on top of the existing structure, creating 3 above floors. And what you see in this image is so striking because everything that you see is reused. Every windows, all the orange metal sheets, the entire staircase, the balcony, the structure in steel, even the solar panel on the roof that you don't see, they are reused. When we go inside, everything here is also reused. The parquet, the entire steel structure, even the heating system were reused. The windows, as I said. The only thing new is the timber frame structure and the plaster, the clay plaster on top of it. Also, the insulation of the facade is new, but it's done with the straw. Straw is also interesting because it's also a waste material in the end. It's the waste of the now I don't have the word in English, but the grano, the grain that you use to make the bread, right? You have the straw as a waste, and then you do normally this cylinder to feed the horses, for example, or the cows. And you can also insulate building with this material. We did some drawings to show this project, and we quickly find out that we needed a new color to show reused element, and so this is something that also got institutionalized, let's say, in our school. When we speak about reused element, we draw them always in green. You know, normally there is the yellow for demolition elements, red for new elements, and now we always start to draw everything in green when there are reused elements. We know that Baubüro and situ use even a 4th color. This is the blue. Blue is when you want to plan to have a reused element in your project, but you didn't find them still. So it's like a placeholder for something that is coming. This graphic shows a map of Switzerland. Here is a winter tour, so the end construction site of the K118, and you can see with those lines all the demolition site from where the the elements, here they're also represented, were taken to create the new K118. And you see is a maximum radius of 90 kilometers. There were almost 25 demolition sites where there were different elements, no? That they were picked up for the K118. This is also crazy because it means to have a new construction site of a building, you are actually following up parallel 25 different other construction sites that are demolition sites. So you can understand already the complexity of it. This graphic is a bit scary maybe, but it shows, I think, pretty good the complexity of reuse. We find out that every construction element, you see, for example, we took the example of the window, has to go always through 10 phases when you want to reuse one of these elements. So you have always to search for a window. There are different ways to search for it. Then you have to assess and document it. So you have to understand if a window has the good quality to be reused. There are different tests. Also construction physical tests for a window in the glass, the handle, and of course you can imagine every element, every different element has a different test. It's different to test a steel profile than a window or a door. So the architect has to know much more when you want to reuse elements. When the assessment go through, so the test says, yeah, we can reuse it. You have to document it, or it's something you do in parallel, because you have to have precise dimension of it in the sense that then you can plan with those dimensions in your own project. And this has to go in parallel. When everything fits, so the project and the assessment of the element, then you can buy it. So there is the acquisition process. And sometimes the component, the owner of the component is the old client owning the building, but sometimes is already the demolition company that owns the component, because sometimes there are some kind of contracts where the demolition company own the building that they are demolishing it. Then start the dismantling phase, then the transport of all the elements to the storage space, and just after the storage phase, let's say, start a process that we can compare to the normal process. No, the elements goes again to a company. Maybe it's a woodworker for windows, or maybe it's a steel company for steel elements, and they get prepared for the new building. Maybe they need windows need a new handle, a new gummy, insulation gummy, or the steel needs some new holes, etc. And after this, they get reinstalled in the building. And of course, there is a last phase, is maintenance, when the components are inside the new building. And you have to imagine the architect has to go through those processes for every element. And sometimes they get till documentation, then they realize the element is not good, and they have to start again. This means that suddenly there are new business model developing also in this topic of circular constructions, reuse of element. So can be, for example, a client became a circular client. For example, in Switzerland, the SBB, so the National Railroad System, they have so many pieces of land, so many buildings, so many components, for example, the railroads and steel elements, they can practically, and they're doing this, catalogizing all their elements to understand how they reuse, if they have a demolition, how can they reuse the element in another project. But can also be a circular planner, like Baubüro in situ or Rotor. Rotor even better, maybe you heard already last week. So the Rotor, they bought their own storage space, they're dismantling the element, bringing the storage, they sell them, having a new revenue stream. but also a circular business. Like there's Philips, the electronic device producer, that they produce those lights that they installed in the Schiphol airport in Amsterdam, for example. And there's this idea that is not anymore the airport owning the lights, but they remain, it's like a kind of lease, no? Philips lease the lights to the airport, they maintain them. If when at the end of life, they take them back and they replace them. Or circular suppliers, so it means maybe a producer of windows that start to also to take, go in demolition site, take back some windows, repair them, storage them, and sell them. Then this graphic, that for us was really important. So as an architect, we wanted really to understand what does it mean to design with the reused element? How does the design of a building is affected? And so we find the way is almost a timeline so we follow the design of the building from the beginning till the end, and looking how the different components found in different moments of time affected the design. And there are some examples. For example, Baubüro in situ found those windows in the area, but they didn't know how to use them. But for example, they were so nice, they had this industrial appearance, but actually they're really bad windows. Iron frame, not isolated, just one layer of glass. So actually there are windows that you cannot reuse. But they say they look so nice, so connected with the place. We want to maintain, to bring them in our project. We put them aside, we will find a way to use them. And then, and so they didn't have a project, but they had the windows somehow. A big idea, so one of the biggest change in the design was the structure. So this is the abandoned structure of a Fertile Centrum, is a storage center in Basel that was going to be demolished. And Baubüro in situ got the news that they are going to demolish this structure. They start to do the assessment, the documentation. They found out the original plan of the structure. They realized so the dimension works good. They could work for Winterthur. Also the loads of the structure was kind of good because it was a storage place. And they realized, doing a quick 3D, that actually the inner structure of this building could have fit perfectly to K118. So just to say, to take this double order, putting on top of each other, creating a 4-floor structure. And so they started to dismantle it, so they bought them to the Coop, that was the owner at the time of Basel. They started all the process of putting on a pallet, storage them, and they started to rebuild it in Winterthur. And at the end, this is maybe I can speak later about this detail. In the end, the funny thing is, because the structure, the original floor plan of the building has a trapezoidal shape, but the structure is a square shape. So this building now has this kind of cantilever element going out that actually was just a gift given from the elements, and it was not planned by the architects. So this was also the things that comes out reusing building elements. Baubüro in situ always talk about this thing: forms follows availability. So you have to follow the forms that comes out from what you have. Other example is the staircase. At the beginning, they thought we should plan the staircase inside the building. I don't have the proper plan, but you can imagine. So that you have ateliers, and they plan to put the staircase here with the elevator. But then in this office building that was demolished, that I showed you at the beginning, they found a staircase that fit perfectly in height with the new building. So they said, okay, let's use it, let's place it outside, and so let's maximize the space inside, moving the staircase outside. There are many anecdotes actually about this design process. Maybe the last one is how they did the facade. These are again the windows from Orion office building. Those are our students. This is also, I like to show this image because with our students, we try always to do this workshop where we bring them on the demolition site, and we let them for one day work with the normal workers and try to understand. Also Rotor does this. I think you saw also from Rotor. We're not inventing anything, but it's really important because then you understand how heavy is a window, how much it takes, how many person takes to dismantle, how many screw you have to take away, how is fixed a window to a wall, and you learn so much. How do you put it on a pallet, right? And so it's an interesting process. And then we always try, as Rotor does, to place them on a floor and discuss about the different material, the quality, the potential of them. And this is also Baubüro in situ doing something like this in their workshop all the time. And coming back to the windows, this is also an interesting moment. You see, for example, those are the windows from office building Orion, and you realize that you have a steel structure with a given height. You have a windows that you find somewhere else with a given height. Then you have the height of the Brüstung in German, so the height of the windows that you have to follow kind of norms, now 1 meter. And so then you have to place all together. Suddenly you have those moments so that you have this kind of tolerance moment where the windows is higher than the ceiling. And how do you solve this? You need to also to have a tolerance system of it. And for example, they found out that a light system of construction with wooden frames is the best way. And that's why also they came in play the straw. So to have a system that can, till the last moment, get some surprises, let's say. Because in a system like this, you can place a different form of windows almost till the last moment. So prefabricated light construction. Because then between the windows and the construction is all filled up with straw. This is a photo of the construction site, and those you see was the end. Maybe some word how we try to transfer all those topics with our student, how we try to teach reuse. We find a way, we try to, again with this glossary, we like a lot of words, and so we define a catalog of topic, and we connect them, every word with a realized project and a closed text. So to create an alphabet, a glossary of different strategy to use when we think about circular construction and reuse. So I will go through some of them. Or for example, continuity. So it means to work with existence, to work with the elements that maybe are already in the same place where you are doing your design, and try to transfer them in your project to maintain the history of it, to keep the meaning of the place where you are working. And as example is the way to the Acropolis from Pikionis, the Greek architect that reuse all the Greek stones to pave the way. But also, a completely different strategy could be to think more in materiality. So it means it could be possible to try to work with just one material, in the sense that try to exploit the quality of one material, in this case wood, and try to do everything with it. It's not always possible, but this could be also strategy. I will show you something that also sometimes contradict each other. So it's not that, but there are different ways of thinking about this. But we find interesting this project from Seiler Lienhardt in Alpnach in Switzerland, because they did this small house where every element above the ground floor is with massive wood, so the slabs, the facade, and it's done with this system where there is no glue, so all the different wooden elements is a kind of CLT, but without glue, because there are doubles, so wooden screw connecting all the layers. So it's a really massive system, but it's done with one material. So in the, let's say in the future, when someone will want to demolish it, of course will be better not, can at least reuse it better, those elements. We can do this same idea maybe with stone. This Peraden in south of France, working just with massive stone, doing a housing project where there are 60 centimeter stone walls, that at the same time they are everything. They are facade, there are insulation, there are structural system, and it's just one material. There are inside facade, outside facade. So this idea to exploit the quality of one material, we find always interesting. But of course there are also other things like separability, legibility. So it means this idea to try to work with light materials and to assemble them in the way you can in the future disassemble them. So this concept also of design for disassembly. A good example is the house from Werner Sobeck in Stuttgart, where you all work with steel elements, all screwed and not welded, for example. But at the same time, the idea of legibility. So those systems, when they come together, has to be readable. You have to understand why a material is used for which kind of purpose. And we thought always this pavilion from Zumthor in the 2000 Expo is Hanover is an amazing example, because he combined wood, massive wood, timber, and steel, but both the elements, they work accordingly to their strength, to their quality. The wood is used in compression, the steel is used in tension with cables, and they are connected in a way that every connection is really exposed, even became architecture in itself. So maybe it's a bit even too much further. We cannot do always like this, but it's interesting to think about those topics. And we have many more, but for example, recording. So this idea to, a bit like Plechnik with those tubes element, canalization element. This is a project from the Kleines Café from Hermann Scheck in Vienna, where he reused actually tomb stones from cemetery, cut them in like a salami, let's say, in a smaller slices, and he create a floor, you know, for in the back of the cafe. So suddenly, death tomb became a floor. So this idea of recording, finding a new function for something, and this is something we always try to do. So we see an element that has a character, has a function, and we ask ourselves, how could we use in another way? Reconfiguration. This is a research project in EPFL from James Jan Brütting. This is about, there are some kind of, for example, steel structure works really good, that they're all screwed together, they create a structural system. What happens if you screw them away and you recombine another configuration? This works really good with small elements of wood or, for example, steel elements. Or addition. Addition is all what happens when you take really small pieces and you put them together, create a new structure. An amazing example is the structural system of Philibert Delors in France, that actually he developed it, and he wrote about this construction system in a book, in a treatise, and it became so famous that actually nowadays, if you go in the south of France and you see a roof like this, it's because of this treatise of Philibert Delors. So that in a time of scarcity, there was not enough wood on the countryside. He invented this idea to say, you can also take smaller pieces, put them together, and you can have a bigger arch and create still a roof structure. So, really fascinating, actually. Or oversizing. When we deal with reuse, there is always a matter of oversize. It means you cannot find the precise element for your precise function. Sometimes you have to take something, reuse something that have more quality for what you actually need. So you start to oversizing the things, but this you have to work with it. And we find interesting that the example of this house from Anton Garcia Abril ensemble in Madrid, where he actually even accentuate this, taking this huge industrial element to create a house. And we develop all these topics during some semester we did. Maybe I go quickly through this. But for example, one was we gave our students the same catalog of Baubüro in situ, and they had to build their own K118 on the same plot. So it was fascinating to see how many different kind of project, the differentiation, the variability of the solution we got. Or even we investigate a SBB, a railroad storage place in the center of the city of Zurich, and we propose to analyze the entire structure, make a catalog of it, and with all these elements to produce a school inside it. And we even did an exercise producing some lamps with reused elements, and one of the lamps now, and then the client of K118, they found it so nice that now they produce 8 of them with the neon tubes, not functioning neon tubes, and now they are in K118. And so those are some projects of the reusing of the storage space of SBB. Or we even deal with one-to-one elements. We did a summer school developing mock-up of one-to-one facade with reused element. This was myself with a small camion going around Switzerland collecting elements like bricks, steel plates, roof tiles, and then filling up all of our building and letting the students produce one-to-one mock-ups. Coming back to K118, maybe I show you those last graphic, because we also analyze in the end, okay, you do everything with reuse, but what does it mean in terms of costs? Swiss francs cost, so money, but also gray emissions, so greenhouse gas emissions. And these are the costs. In the green column, you see the cost of the reused element compared to the gray one will be the new element. We analyze the cost of all the material actually, but we select 10 of them, our protagonists, and we follow them from the beginning till the end. As you can see, almost those components, like the doors, the windows, they cost less, sometimes even 40% or even almost 55%. There were elements that were costing a bit more, like the entire steel structure or the stones element or the parquet. This graphic shows the entire cost. Is a bit complicated, but it's interesting to see. This is the beginning of the project till at the end of the project. And maybe for you to take out as takeout is that actually this building K118 costed the same as a new building, built with the same materials. But it was interesting to see on this red line, you see there the starting of the project, of the construction site, right? And here, above this line, there are the construction costs, and under this line, there are the planning costs. It's interesting to see that there are already 10% of the costs already happening before the starting of the construction site. And so in this case was almost $500,000 of Swiss francs. And you have to imagine this is a lot of money, because normally before the construction start, you almost pay just the architects, the planners, the engineer. Then they get the building permit. After this, start the construction site, and you pay the construction firm that buys the materials and start to build. But here, you have to collect all the material even before starting the construction, even before having a building permit sometimes. So you have a much higher risk. This is a point of dealing with reuse elements. And this is for you, it's the same graphic, but it's with the greenhouse gas emission. Maybe I can go directly at this one. So if you remember the last graphic, this was Swiss francs cost. Here is green gas emissions. And you see how almost every component save in the black, you see, between 80 and 95% on CO2 emission. Actually, the green part, so where they still consume some emissions, is in the transport. So to transport the element 90 kilometers away from a place to another, so consuming diesel or gasoline, this is the main amount of greenhouse gas emissions. But still, it's really 10%. You can even drive 2,000 kilometers away, picking up some element, you will still be actually saving CO2. And the main result, the last slide, is that this building, K118, saves almost 60% of CO2 emission, almost 500 tons of greenhouse gas emissions, compared to a normal building with the same size, with the same material, but new. And as I said at the beginning, this is a striking result. It's almost impossible to get it with other strategy, like recycling, or, the only other strategy will be recycling. Because also, for example, there are many now speaking about design for disassembly. You should design everything that is dismantleable, that maybe in the future you can reuse them. It was about design for disassembly. So design for disassembly, in the end, you produce everything new, so you consume already all the emission. Then maybe with the idea that in 30 years you are going to dismantle it and or disassemble it to reuse it. But in the end, you already consume everything. So it's not so effective. The reuse of building elements as they are is a really effective strategy. So some findings of it. Well, actually, we already spoke. So reuse enables drastic saving in greenhouse gas emissions. Reuse changes the evaluation of building materials. So suddenly, instead of maybe a single variety, let's think about concrete, puring concrete, you start to think in layers. So suddenly the hybrid construction started to be again interesting. Steel construction mixed with wood or even stone. So to put many different elements together started to be again interesting. Of course, construction method change. Reuse means, or circular construction means to work with light materials instead of solid, heavy material. And the connection, screw clamp, plug instead of adhesive, instead of gluing things together, or weld metal together. Reuse affect financing. We saw that you have to invest much more money before the construction starts, and this can be a problem if there is a private client with not so much money that cannot take the risk. In this case, it was perfect because it was a pension fund. That also they don't want to have so much risk, but they have much more money. They have bigger client. They can assume some risk. Reuse promotes local value creation. Suddenly, you start to work again with the people around you because you need a small company maybe helping dismantling windows, doors, removing tiles. So you reactivate a kind of a small business, and you even create new business model, as we saw. And now maybe those were the findings, but actually the biggest findings we had seeing the K118 was that we need to develop new example. So the best way to develop to enlarge the circular construction or reuse of building element is to create interesting architectural example that can communicate this process. And K118 was a lighthouse project that actually started a movement, we can say, because it really created a movement of reuse, and many other projects follows. I will show you really quickly some of them. They are actually, all these projects are actually in planning in Switzerland. For example, this ZHAW Recycling Center in Zurich, where there was a open competition, where there was also given a catalog of elements, for example, the entire steel structure, and the winning proposal was from Graben and Pulver. Adrian Kieser was also working with them at the moment, and now is a researcher with us. And so they propose to reuse completely the steel structure, plus even creating a new office building with reused concrete element. And now as a university, we are following all this process. It's like a new K118. It's interesting because the city was really involved in this process, so they create an open competition. They create a catalog. You can still find it, I think, if you look for ZHAW store. So there is online a huge catalog of elements that everyone can use for their own project and actually buy them with a really low price to the city of Zurich. The same happened in Basel. Basel is also is on a website with catalog of elements. They are creating new competition based on those catalogs. And here, so you see, we are following this project of ZHAW, and just this summer, the existing structure in steel was dismantled. We follow all the process, and it's really interesting to see because is everything new. No, we just realized also in this process here, the firm dismantling those one is not the same as the one transporting them away, is not the same one taking them away from the storage and reassemble them, and no one of them communicate with each other, for example. So so it's really difficult. There is a lot of work of communication, direction of the construction site from the architect point of view, because it's kind of not an industrialized process. We, as a researcher, we are also developing research in the direction of reuse concrete element, existing concrete slabs, and we just built this pavilion, this mock-up in front of our university. We'll have a vernissage this week, and you can see we are trying to develop a new building system done just with reused concrete element. Those were coming from 3 demolition sites, and there were balcony plates. And just the beams are new, all the other elements are reused. The idea will be in maybe 5 years in the EMPA building in Zurich to build really a 3-story high pavilion using a new system. And of course we are researching now how really it works to put together concrete element with steel elements together, because of course you need also steel. We also was involved in this project from SBB. Gigonguye won this competition in Switzerland, in Zurich, reusing railroad elements, welding them together to create a new steel structure. Also, Adrian Kieser was involved in this project, and now SBB is going to build it. So it's an entire structure in steel, reusing railroad element. And we are also will follow all this process. This is another project in Basel where it's more fine reusing, but they, I don't know if I have a slide there, but for example, they reuse the windows element outside, all the roof tiles, creating a new facade. It's also interesting because they work using different height of those elements. Suddenly they create a new facade somehow. So you have long windows, French windows with these double elements that you can open, you can close, you can create different situation inside, light situation, but everything is reused. There are many things, also those silos. Or this building, this competition in Basel, where also there was a public catalog of this parking lot, a 4-story high parking silo, all done with the prefabricated concrete element. And this building, and all this building was planned for the city of Basel to be dismantled and to create a catalog of elements to be used for a competition, a housing competition. Para Basel won with this proposal. And you can see how radical the proposal it is, no? To reuse the entire concrete structure and to even use the slabs, the prefabricated slab element, as a facade. Now they are now in the building project. We are pretty in contact because we are also following this project, and of course there is a lot of complexity in it. They are a bit struggling it, but actually they will manage to do. Is going to be an amazing project, because you can imagine it's a 100 million project with 160 apartments. They are all done. It's almost a new village, a small new city, all done reusing an entire parking silo. It's really an amazing project. And maybe closing the lecture quickly, also we as NUAR, me, Adrian Kiesel, Marco Guerra, Iso Tambornino, and Stefan Hauser, we are also trying to, in our practice, to develop those topics about circular architecture, reusing element, and we had the chance to win this competition for a primary school and a kindergarten in ZHAW in Engadin. And we started with this idea. We were fascinated by the fact that actually, because of climate change, there is always less snow around, even in Switzerland, the mountains, and a lot of ski gebiet, so ski elements are getting abandoned. No one is using them anymore. And so there is a huge amount of these steel pillars hanging in the landscape that no one uses anymore. And so we thought it would be interesting in Engadin, in ZHAW, that is an amazing history, is this valley. Maybe if you know, it's 1,500 above the sea level. It's really, and there was really always a rich valley because it was the connection between Italy, Austria, and Germany and the North Europa. And so they used to build these really massive houses. We had in mind this idea of the pillars, the ski lift pillars, but also knowing the traditional construction of Engadine. They are really famous with this kind of windows, because historically at the beginning the houses were always done in wood, and then with the time and getting richer and richer, as with the market, all the people passing through in the Renaissance, they started to build really heavy, massive stone walls around them. But of course, creating this kind of elements in the windows to bring more light in them, in the wooden window, in the inside layer. Putting all together those things, so here you can see a bit the evolution of the house, Engadine house, having always with in the corner, the massive corner in stone, and the filling of wooden elements. So we thought it would be really interesting to try to create a really compact building, but also to reuse these massive ski lift pillars and create a structure like this. And so to have this kind of image in the inside. So have the ski lift pillars filled up with the cleancrete. This is a concrete made of clay, with clay cement, so really poor in greenhouse gas emissions, and to make them as the main structural element of the building. And because they are so big, they are 70 centimeter per 70 centimeter, they are even whole inside, they are empty, and we can even place all the technique inside, the air and the water pipes and everything. And this is a bit the scheme that we did. So coming from this one, putting some wooden frame, puring the concrete, adding a new capital where we can connect the wooden beams and the wooden floor. And so we imagine, this kind of new structure. We even went to look for them. We already take all the measures of at least two systems that are in Andermatt. We even did a scientific paper calculating how much is precisely the greenhouse gas emission of them, and also compared, for example, because this is also always the question. Maybe they are okay, we save some energy, but what will be if we do it in wood? We build them in wood or even in concrete. We try to do a life cycle assessment of it, and we saw that actually they will be still competitive with a wooden pillar, even if we will have to use a helicopter to move them around, take them away from the landscape. And this was also an image we wanted to move to say we are trying to create a new order, a new circular order, even inserting is a bit ambitious, but it was we thought it was funny. We thought it was a fun idea. Yeah, and in this way, practically putting also the pillars in the facade, they became also facade, they are structure, and at the same time, they recreate this kind of Engadine windows, having these elements bringing the light inside. So we find out that all these elements together could create, at least for us, a good piece of architecture. And the funny thing is, just to close, that we didn't want for the reuse. It was not written in the competition program that we had to reuse something. We just proposed because we want. And but the starting idea of the reuse create the entire project, but still we managed to win. And so also to say that, architecture, to do architecture is much bigger than just reuse. So many different things has to feel together to create something I don't know if this is good or not, but at least it's something convincing. And so reuse is a part, but it's interesting to think about and to use it as a tool to produce also another kind of architecture. Yeah, this would be my close. Thank you. Thank you so much. A bit longer. It was a bit longer. Maybe you have a question?
Concerning guarantees for such elements are used. For example, it's a different story if we are talking about windows or about bricks, but even bricks, construction companies need certificates and so on, and this is, I think, is the biggest issue, how to introduce reused technology and material in broader practice. So I'm interested about what is your experience in Switzerland with this problem?
Yeah, in the end, yeah, so is it a problem? Because of course also the clients, they want to be sure that what is going to be built follow all the norms. There are always more norms in different ways. So fire, it's good to have them. I'm not saying so the fire norms, also the insulation, sound insulation between different rooms, or the temperature insulation. And the thing is, yeah, in Switzerland is a bit easier in the sense that not being completely part of the EU, Switzerland can have its own rule, and there is a kind of way, if you prove with tests, so you have to do practical tests, but if you prove that your material could work, your reused material, then you get the certificate. This is something much more difficult than in Europe. And, but of course, again, it's a huge topic. So you need a committed client as well that wants to take the risk, spend maybe more money to do more tests. And so that's why also we really try to push, and we find it really interesting that also the cities started now this process. So city of Zurich, city of Basel, they're developing their own competition about this topic, and they are ready to take some more risk, because of course as a private client it could be much more difficult. And for example, then is also depending of the material, because bricks, for example, then they're really, for example, bricks, we cannot manage to reuse them in Switzerland, also because we don't have so much of them, we don't have the tradition. Reuse also has to do with the tradition, or Baukultur, so which kind of elements you find in your region. And but bricks are also this problem that the really old one, they were put together with a nice mortar that you can take away easily. But now, I don't know precisely when, but then when they start to use cement in the mortar, it's almost impossible to take them apart. When you try to take apart the bricks, you destroy them. And so, and then the process really physically to take them apart, put on a pallet, bring in a storage, is too much more expensive, unfortunately, than buy them new, because the material costs are nothing. And so it really depends also from component to component. Yeah.
Okay, thank you for that interesting lecture. How on earth, I mean, construction contractors are not renowned for being charities. So, construction contractors are not renowned for their kindness and generosity in general. No. How on earth do you control the costs when you're reusing all these elements? It must just increase the amount of unknowns and unpredictables.
Yeah, again, I'm speaking as an observer for what Baubüro and situ have done. No? I'm starting this process myself. But so for what I've seen in K118, of course, was a big issue. The thing is, they had to develop a way, also a legal way, how to do the tender call, right? Because you have to, for example, in the case of the windows, you have to do a tender call, giving already the material. So not asking for new windows, but you say, okay, we have already 45 windows in our storage. You can go to check them. They are so done like this, like this, like this. We think we need to refurbish them. Maybe we have to change the gummy of 10 of them. We have to change the handle. So give me the price of every of these things. Then they also ask, for example, for the windows, give me the price. What happens if we break all the windows, or at least we break 5 of them in the process? Give me the price of the same window new, so because you will have to deliver a new one. And so in this way also, we got also how will be the price of the same building new. So this at least was a way to get the price. And so, but of course was for every element was a bit different, no? How to create the tender call in the sense that still there were enough company to apply to it, but of course there were not so many. There was, and most of the time, the company applying to it, they were the same involved from the beginning. That they were dismantling already maybe the elements, knowing them, having a bit of insurance, so safety on it. For example, the steel company that dismantled the steel structure in Basel was the same, and then remounting it.
Did you look at the overall cost of that project that you looked at, as to see what the tender cost was, and then how it landed when it was complete?
So we look at the cost. Maybe I went a bit quickly through it. So, but we
that was the elemental cost.
So we look at the cost
elements.
At the end. Let's say the building was costing the same as a virtual one built the same way with new elements. Maybe 5% more, but let's say in the range. So was a normal cost for a kind of addition, but of course, in the sense, then it's also a matter how you manage the old tender call. But in the moment that you are precise in the cost, so describing everything, they got an offer, they accept it. Of course there were maybe some minor addition, but then it was okay. In the moment that a company, they were saying yes to the tender call and getting involved, and this was the price, at least. Yeah.
Hello. I would like to ask, what's the difference between, you compared quite well the cost and this part of the project, but how is the comparison with the normal project and the time-wise building the construction site or building the building, actually?
Yeah, this is a good question. So you're saying also maybe this building took 6 months more to be built, or and so how do you calculate this much more time in the construction site? The thing. No, it's a good question. We did also, let's say, the problem is always in this comparison. You cannot really compare in the end because you don't have in the same site building the same building, right? the construction didn't have so much delay, because in the moment that they started, in the end, it's a really fast construction. If you think about the steel elements, you can build them pretty fast. Facade element are light construction. You prepare them all in the factory. I have built images of it, but so. And then you bring into the construction site, and in 1 week you have the facade, maybe 2 weeks you have the facade. So in the end, the huge amount of time was in collecting all the elements, but the construction site in itself was not much longer. Of course, if we compare to, I don't know, maybe, but I don't know, still even a normal concrete building, they come, they do all the slabs, maybe it's faster, but maybe not. I cannot answer this, but there was no delay. It was not really longer as a construction site, yeah.
Okay, thank you. It was more like a general question about if we say that we're building from reused materials, there is like always some kind of percentage of time which will be added to the overall time.
For sure, there will be much more time for the architects in looking for and looking after all the elements. But of course, this is also interesting, at least in this project in K118, the architect could get additional fee for it. They call it Bautaljagd, so the hunting of the components. Because actually, when you think how the price of, again, the windows, the price of the windows, of the reused windows, is made of these 10 phases. And so to buy the windows in the demolition site doesn't cost so much. Maybe they pay them even, I don't know, maybe 50 francs or 50, I don't know. So it's nothing, I don't know, not so much, 50 euro to have a kind of a. The problem is that then is the cost to organize the dismontage of it, the hours of the people dismantling them, the transport company coming with the camion, picking them up, bringing the storage, the miete, the renting cost of the storage that has to be stay there, the window for maybe 1 year, waiting for the construction site. And adding all this, then in the end, at least in K118, they cost still 40% less. But actually, yeah, of course, you have much more time in organizing this. And architects is also part of this process because, for example, to draw the drawings of it, to organize the logistic of it, they got some money from the client. And so part of the cost of the elements actually are expenses paid to the architect to organize this. So the architect gets a bit a higher fee, but of course also more work. Yeah. Yeah. But time delay, yeah, it's difficult to define. Yeah.
Okay. Hello. Thank you for your lecture. I wanted to ask, because you showed us several graphs showing what is the comparison between building from reusable material and from new material. I wanted to ask, what methodology do you use for comparing these aspects? Because I can, of course, see that you could somehow stage it to always look very green, and someone who isn't that green would stage it to look not so green or not so good for the reused materials. I'm not saying that you did that. I'm just asking, what is the methodology?
But you meaning with the CO2 emissions?
Yes, CO2 emissions and life cycle assessment.
Yeah, so to calculate the emissions of this building, we follow the system that we have in Switzerland. So we have a table called from a KBOB. So there is this public organ of all the public clients of Switzerland that they organize this table that you can download where you have the UBP value, or in European value will be ADP, and even you can have for every different materials the CO2 equivalent emission, no? For many materials, wood, concrete, steel, windows in different shapes. So to calculate the emission of this building, so we calculate the exact same building with all new materials, and you can get how much will be. And we calculate actually, so with all the reuse elements, how it was in reality. So our windows is the scheme that I showed you at the beginning. If you reuse a windows, you don't have to calculate again all the manufacturing process, so the extraction of raw materials, all the manufacturing process, because it exists already. So this is zero. At least there are different ways of calculating this. This is the cutoff approach. You can say that this is zero, and so what you have to calculate as emission is just for example, let's say the windows, I don't know, but you need a machine, a crane with a gasoline camion to take the windows, move it. Then you have to calculate how much benzene you use and how much you emit. Or if you use an electrical Schrauber, so
drill.
Thank you, drill. I'm mixing up too many languages. You have to calculate the electricity, how much it is. Then to transport it to the storage, the camion, how much diesel or gasoline. But so you calculate the exact process, and that's it, actually. And then you realize that windows consume, logically, so almost 90% less, because in the end you compare the full production of it, maybe with aluminium coming from China, because those windows from this office, they're aluminium windows, triple glazed, no? Aluminium come from China, in Europe, maybe through container, then is maybe in Germany, the frame is done in Germany, then transported to Switzerland, they will put the glass, you can imagine, no, the effort. And we reuse it as it is, you just save all this process. Did I answer your question, or?
Well,
no.
I was asking specifically about the methodology, but you said that it's from the Swiss book of methodologies.
There is this table, of course, it's this KBOB table where you have all the data for almost every material. I cannot explain you precisely how do they calculate this.
Okay.
But yeah, because in the end is, of course, for example, our windows maybe in Switzerland, there's a different value of our windows here in Prague. And that's why there are different actually value in different countries. It's a huge topic because of course we are connected always to table, to data, to calculate and to have then a result, a number that we can compare. But at least if we think about, as I explained, all the process, no, for sure it's better to reuse a Windows already there than to start again all the process.
Yeah, okay, thank you.
It's good.
I think there's... Jindřich.
I have yet another stupid question. I was wondering to what extent in the design process did you try to explore possible architectural expression and make, say, decent architecture, and to what extent you try to make the job as easy for you as possible? Because I feel there is some kind of polarity in the process. You can either make it as efficient as you can, or as innovative in terms of expression, let's say.
Sorry. You said normally you try to do as easy as possible. No, when you design something.
I mean, the process as you described it,
It's complicated.
It's complicated.
Yeah.
And I was wondering to what extent you try to make it just like as easy as possible, as like I don't know, not taking into account any kind of aesthetic, you know.
Yeah. This is this is a really good question, and it's also an open question. There is no answer. So, for example, the Baubüro and Situ, they really built this building, and they're really much into this process than me. I'm just observing it. For example, they say we don't care about the design. We just really put the things together how we found them. Form follows availability. Because they say, so it's too much effort, we cannot, there is no time, there is no money. It's already enough that we found them and we could reuse them. We just of course it's not like this, right? So of course they have this kind of, there is a new aesthetic somehow, no? Because also, now I'm thinking, it's all recorded what I say. It seems I'm saying Baubüro. It's not true. They also have their own aesthetic in putting the things together, and it suddenly became something new. So as university, still a bit theory. We try to ask ourselves if we can even a bit. Work with it and try to use it to control it a bit more. I don't know if we manage. Maybe then in the reality, the way as Baubüro in situ does is for sure more close to reality. But still, they also they could took different colors for the facade or even mixed different colors, but they found that this orange color was really connected to Winterthur because there are many buildings in the area with this color. Or then the facade is not straight, but they move it a bit, so in section it grows always a bit because it's also a way to cover the system of the windows, and they also get this building going a bit, getting bigger with the height. So of course there are the fine tuning of it, and they are also radical in the sense of saying, no, form follows availability. We don't want to think so much about it. And yeah, it's a matter of how much one is involved in it or not. Personally, when we try to design something, we try to put everything together. So to have an element that can tell an interesting story, that can be reused with a new function, as with the pillars. In this case, a pillar became a pillar, but now we are working also with the steel tubes becoming something else, or we know about building being demolished with an entire floor system that we are trying to cut and reuse in a new building. So, and how we can integrate this in the design. But of course, it has to work with everything, with the program, with the functionality, with the with aesthetic. And I don't have an answer. Maybe in 10 years I can give you a better answer with some build example. I hope. Yeah.
I actually wanted to wrap it up already, but you have the last question, so it should be the best one. Try it without microphone, even now.
Hi, thank you. It was a really inspiring lecture, and I'm just wondering if you are thinking about some possibilities of reusing like panel constructions from the housing development in the past, because the lifespan of this building is going to end like someday. So
I didn't understand. Sorry. So can
yeah, if you are thinking about the reuse reusing or some possibilities of reusing the panel constructions of the housing development of the second half of the 20th century.
But you mean panel construction, this concrete, like the DDR system?
Yes.
Yeah, there are studies of it actually from FFL in Lausanne. You can look for it. Or there are some architects in Germany that they did a small house reusing those elements. But of course, also for us, actually, Adrian Kieser is going to start a PhD really about this topic to say how can we learn from this building system with the prefabricated concrete element and to apply all this knowledge in reused concrete elements. This is a bit something else, but all these buildings, there is a huge potential of it. There are urban mine full of those slabs, floor slabs or walls. Of course, they don't follow anymore the standards, so they have too less insulated. Also, a slab, maybe in the moment that you cut them away, because they're always connected, they're placing together and they're filled up with a concrete. I think with the steel going through, if you cut them, their structure they don't work anymore so too good. But then start the thing. No, you have first of all to analyze precisely the system, understand it, as well as you will be the producer of it. You really have to understand. Then you have to start to combine. Maybe you can put two walls together, or maybe connect them with steel elements, leaving us space in between, and putting insulation, maybe straw, and then you have a new facade. Or you can. So then you start to think about. But yeah, at least it's what we do. Yeah.
Maybe like there was this in Venice Biennale in 2012. This German pavilion was quite focusing also to the situation in Germany, which is maybe somehow more similar to our situation. Which there was also the catalog called reuse, reduce, recycle, or something like that. So there was also like collection of examples and references and strategies how to work also with these structures. So maybe you can also look at this book if it's in our library, or you can maybe buy it online. Okay, thank you for the lecture. Thank you for coming, and have a nice evening, and Merry Christmas.